I wanted to introduce our speaker, Kara Thompson, who is a data visualization consultant who builds stories with data and is a longtime favorite at our medicine. She has a gift for explaining how to turn data into understandable visualizations that communicate a clear message and specializes in helping people turn their data into clear and compelling visualizations. Her workshop today is titled Visualize, Optimize, Parameterize.
Thank you very much. Can everybody hear me okay? Could I get a thumbs up from somebody? Yeah, good stuff. Thank you very much. So thank you all for joining. We have 3 hours ahead of us. I don't know if it will take all 3 hours, but we can make the most of that time. And hopefully we'll have plenty of time for questions when we get to the end of the session. Today I'm going to be talking about how to create visualizations that should make your life a bit easier. We're going to be talking about parameterizing our code. We're going to be talking about creating reusable bits and pieces. There are some exercises for you to do if you would like to code along. And I will make sure that I share the relevant bits of code as we go so that you can have a play around with all of that. We have Gabriella, can you give us a wave if anyone can see? So this is Gabriella. She is going to be giving me a hand, making sure that I don't miss any important questions in the chat. So yeah, interruptions are absolutely fine. And hopefully you'll all be able to follow along as we go. So without further ado, let me share my slides. And you should all be able to see something, hopefully. Yeah, you can all see my slides. Okay, so visualize, optimize, parameterize. It's quite a difficult word to say. And Peter was joking earlier that Americans are very fond on Zs or Zs, as you like to call them. And I've gone for the S's. So that will be me reinstating my Britishness, I guess, as we start. We're going to be talking about visualizing our data and doing so in a way that we can play around with what goes into it. And because you did a good story to keep things going, we're going to be putting the penguins into a beak-off challenge. So I've done the bake-off in previous sessions. This time it's a beak-off. So they are having to win according to some characteristics to do with their beaks. So that's the story. I'm just going to move a few things out of the way there and admit the guests. So we've got 3 hours. We probably won't need the entirety of that, but we'll see how we go. I will upload the slides to my website after the talk today, and I'll share the relevant bits of code as we go. So for those of you that I haven't met before, I'm Kara Thompson. And I'm a data visualization consultant, and I got here through a continued love for patterns in music and in language, and a fascination with the human brain and how we make sense of stuff that is ultimately just noise, but somehow it's meaningful and it's beautiful, and that's really weird if you start to unpick it and think about it. So I took that into a PhD in psychology, which I really enjoyed. I put electrodes on people's heads and got them to listen to really weird sentences and pieces of music and saw how the brain reacted. And so, it was really, really, really fun doing that. And then I took the statistics from that into the world of postgraduate medical exams to help surgeons make sense of exam data. And really found that visualizations were a good way of helping them engage with the patterns that were in the data as we were doing that. And then I did 10 years of that and decided to set myself up as an independent consultant, which is why I'm here. The thing that drives me in all of this is helping others maximize the impact of their expertise. So hopefully that'll be something that we'll achieve for you today. If it's taking a little bit of the heavy lifting out of creating a visualization and allowing you to focus your expertise on really what the story is, or maybe what the stories are across different iterations of your data, then that'll be job done and mission accomplished for me. So I talk about lots of things when it comes to visualizations, and we'll get a bit of a taster for the usual stuff, but the focus really is on parameterizing our plots. And I really love parameterizing visualizations. So here is one that I created for the Tidy Tuesday challenge that some of you may already be familiar with. Somebody releases a data set every Tuesday, and your job is to make something beautiful and engaging with it. So this data set was about how people spend their day in different countries. And because I'm British, but I grew up in France, I thought I would compare how British people and French people spend their time. And there's quite a lot of stuff that's similar between the two, which is interesting. Thank you. Yeah, so it's a fun visual to create. But the really fun thing is that with just a few extra lines of code, you can make it do this. So you can circle through the different countries, and you can say, actually, I'm really interested in comparing, Albania and Taiwan, for example, and seeing how they compare their days. So you can get quite a lot out of, it's an effort to create the first visual. But once you've got that, it's not that big an effort to get it to work like this. Kinga's saying this is the first time I've seen a pretty Sankey plot. Thank you, I'll take that. It's actually 3 different plots stuck together, but that was the way to make it work. But yeah, so it feels like you've put a lot of effort into creating the first plot. You can copy paste stuff all over the place, but then if you make a design decision that means you have to change anything, you're having to change that all over the place. Or you can spend a bit of time turning your plotting code into a function, and go from there. So why should you parameterize your plots? Hopefully you're here because you're already convinced that it's a sensible thing to do. Those of you who are asking about the slides, I'll share them after the talk on my website. So why should you parameterize your plots? Well, I kind of got into this because I was helping the surgeons understand exam data, and we were running the same exams time and time again, but with different candidates. And so we needed to create the same graphs to show how the candidates were doing, but obviously it was different people coming in, but we were interested in the same things. So you can either recreate everything by hand every time, or you can write your code in such a way that it can take in the new batch of candidates and produce a variation on the same graphs. So reporting on different iterations of your data, that might be a reason for doing it. The other reason could be that you want to set up your visualization before you have all the data. Now, those of you who are into very pure research, I'm not suggesting that you cheat at all. I'm suggesting that you kind of get ahead while you're collecting your data and try to set it up with some dummy data. And then that means that when the real data lands, you'll be able to make really quick progress towards the finished product. You might also want to use subsets of your data and to compare different groups or different scenarios. And that can be a really good way to do it. So either you end up copy pasting your code, or you parameterize your code in such a way that you can do that in one go, which is useful. You also end up making life easier for those could you just moments. So when somebody comes in and says, oh, could you just do that again, but exclude this candidate? Or could you do that again, but actually I want to see the data from last year? Rather than having to start all over again, you just should be able to feed different data in and get something fairly sensible. Or someone comes in and says, I don't like the font. What do we do about that? You can copy paste the font name into the 25 different iterations that you've got of your plot code, or you can change it once. And so that's really the key for this. It's making life easier for yourself, for your future self, and potentially for any colleagues that end up picking up your dataviz code. I'm squinting a bit because the sun is really, it's 7:30 p.m. in Scotland, and this is the time when the sun lands in my study. So we're talking about making life easier for yourself on lots of different levels. And it's also to avoid this tension, when your colleague comes in and says, I thought I'd lost that data, but I found it, we can include it in the plot. And you go, oh, yeah, that's great. I've just finished doing the annotations. You don't have to have that sinking feeling of, oh no, I'm going to have to start all over again, because you know that you can just rerun the code and it will all be fine. So it's really quite fun learning how to do this, and it should make your life easier. And this is a project that I did for a client fairly recently. He was analysing different aspects of workplace culture in different organisations. And so you can see how having these set up like this means that we can quickly generate all the plots in one go. And we can also very easily compare different organisations to each other to see where the different strengths and weaknesses might be. So in doing all of this, there are a few traps that we need to avoid, and these are traps that I've fallen into. And so my goal here is to avoid you falling into the same traps. So we'll cover them together. I will share warts and all where I've gone wrong, and that means that you can have the shortcut to avoid that. So one thing that happens when you parameterize your plots and you don't think about all these things in enough detail, which is where I was, is that your colors end up jumping around. So you've assigned different colors to different groups, and then you create a plot in which one of the groups is missing, and ggplot just goes, oh, that's okay, I'll just take the first two colors, even though maybe the two groups that are left were actually the last two colors rather than the first two in your group. You also need to make decisions about your axis limits. So if you want your plots to be comparable across different iterations, do you want to keep the axis limits the same? So that will mean that you don't end up with your axes jumping around, which makes things very difficult to compare. Or do you want to let your axes float because you're more interested in seeing the trends within each group? These are decisions that you have to make. You might end up with your annotations landing in the wrong place, and we'll talk about that in a bit. If you're putting annotations into your graph to highlight different things, they can end up jumping around, and that can be quite messy. You might not be able to get hold of a variable that you need, so you've plotted it, we're talking about the penguins, so you might have plotted it by species and you want to plot it by island, that can be quite tricky as well. So we'll cover all of this today, and if there are more things that I haven't thought of, then we can get to that in the Q&A at the end. So you can parameterize things for lots of different reasons. As I said, different data sets of different iterations, different presentation contexts. So you might want to have a parameterized plot that works for when you're showing it in a presentation, and that you can then quickly rerun if you're putting it in a paper, in which you might want different font, you might want different text size, but you don't want to have to rewrite the whole thing. You might be asking different questions of your data, so grouping people or grouping participants in different ways. You might want to do some clever ID matching so that you can then use the file name to make sure you send the right file to the right person, all that kind of stuff. And ultimately, you're parameterizing for your own sanity and to help with the maintenance of your code. So in order to give us a story, as I said, we are going for the great penguin beak-off. People who ask me how much I've gone into AI to help me with my dataviz, I haven't really, but I quite enjoy the odd image, although to be used with caution, because we're all aware of the ecological impact of that. But the great penguin beak-off is where we are here. So the penguins, there's a great data set, Palmer penguins. They live on 3 different islands. We know how long their beaks are. We know how big the penguins are. We know a whole bunch of stuff about them. We've even got some ID tags for them, which is quite fun. And so we're going to use their data and imagine that they decided to launch themselves into a competition. I'm going to ask you if you would like to code along, and I will send you the code that you need in order to do that. We're going to be using the Palmer penguins. So I'm aware that in the latest version of R, the penguins are included, which is great, but they've changed some of the headers, and so it's just a little bit more messy. So I'm going to use the Palmer penguins just so that we're all clear that that's the data set that we're working from, and so that you're not needing to have the most recent version of R if you don't have that installed. Where possible, which is most of the place in the code, I'm using namespacing. So this is where you use this kind of double colon. I'm using it for 2 reasons. One is that it allows you to see exactly where each function comes from, so which package each function comes from. And it's also really good practice. You don't want to load a whole library or a whole package if you only need one function from it, because there might be some functions within that share names with other things that you've already loaded elsewhere, and you can end up in a few sticky situations with that. So we're using namespacing so that we know exactly which function we're using from which package, and that also means that you'll be able to see which packages you would need to install in order to follow along. So if you have an R console open, if you're using RStudio or Positron, you should feel free to install the Palmer penguins package just as we get started. I'll reiterate that there are no such thing as silly questions. I feel I have maybe heard one silly question at some point in my 41 years on this earth, but it's probably not yours. So if you have a question, don't be afraid to ask it. As I said, Gabriella is going to be keeping an eye on the chat in case there's stuff that I miss, but we'll also have some time for questions at the end. If I'm going too fast or something just doesn't make sense or you're completely lost, feel free to interrupt. That's also okay. And I said the slides, including the code on them, will be on my websites, and I'll be sharing code just as we go along the presentation. So what we're going to do, we're going to build a plot, then we're going to optimize it by improving the colors, improving the styling, and doing a few programmatic annotations. And then we're going to turn that into a function. And I think at that point we might be ready for a short break. So we'll take a break, and then we'll get the penguins into teams and see, what we need to tweak as we report on different teams within the beak-off. And if you have a brilliant name for a penguin team in your mind, just note that down somewhere and you'll be able to use it as you have a go at the codes later. So we'll explore different parameterization scenarios and see how we can adapt our code with each of them to make it work. So the first task is to visualize what we're doing. So the penguins, the task really was to group themselves into different teams and try to be the team that had the widest range of beak lengths. The technical term that we're measuring here is the culmen. So that is the ridge along the top part of a bird's bill. So kudos to Alison Horst for this illustration. That's what we're measuring. That's why that's what it's called in the data set. But we're talking about their beaks. So we want to know, what's the beak length? Maybe we want to look at different sizes of teams. Maybe we want to check that we've got good representations of the different penguin populations. And also we maybe want to check whether the mean within each group is representative of the group. So there's a few things that we could want to visualize in the beak-off to make sure that the penguins have chosen the right team. So we want to show the range of the beak lengths. We want to see ideally all 3 species represented within each team, because that would be nice for the good entente between the different penguin species. And we can also show the mean within each group. So here is the most scary looking slide of the lot. We just need to get our data sorted. So we are loading ggplot2 up here. And then I just want to do that as the background process. And then we are going to look at what we do with the penguins. So we're using the raw data from the penguins because I'm going to be wanting to do stuff with their ID tags, which we wouldn't have if we were just using the penguins data. So penguins raw. And then I'm just cleaning the names to make them tidy style names. And then I'm going to just remove from the data set penguins for whom we don't know the length of their beak, because they can't take part in the competition, because that would make the data quite difficult. So we're getting rid of the penguins for whom we don't know the length of the beak. And then head here just allows us to see the first few lines of the data set that we end up with. So the study name on which the data was collected, sample number, what species they're from, where they live in terms of region and island, whether they're an adult, which I think all of them are actually in the dataset, and then individual ID, and that's just a little ID that each penguin has been given. So then we're going to use that as our penguin DF, penguin data frame. So this is the data that we're going to be using. It's a little bit cleaned up compared to the data that just comes straight out of the package. But again, I've made that clear in the code snippets that I'll be sharing. So we've got some data to work with. So the next thing we want to do is create a graph. So here what we're doing is we're piping the data in. So the penguins DF into ggplot, and then we're using geonPoint with on the x-axis the beak length and on the y-axis the species. So let's see what that looks like. And it looks like this. Not super pretty, but functional. We have a graph, which is always a good starting point. I'm going to avoid all the dots overlapping with each other. And so to do that, I'm going to move to geom jitter, which we can see just here. So we're jittering the points, but we also want to not jitter them completely randomly. So we want to make sure that we're controlling the width, which is how much it jitters on the x-axis. So we don't want that to jitter at all, because we're interested in exactly how long the penguin beaks are. So we need to make sure that we don't do that. But we want to jitter the height, but we want to control it so that they're very visibly still within the band that they belong in. So that's why we're controlling the width and the height of the jittering. I'm then going to color them by species. I've chosen shape 21, which is the circle that has a contour and outline to it. And I'll explain why in a minute. And so then it's the fill that we need to control. So the fill is mapped to the species. So we've got the Adelie, the chinstrap, and the gentoo represented with the 3 different colors. I then thought we might as well add a bit of meaning. So we'll put the size of the penguin as the size of the dot. Just fairly intuitive mapping going on there. I also, oh sorry, it's highlighted the wrong line. I also thought, should we make them triangular since we're talking about beaks? But that felt maybe a little bit too much with shape 25 there. So we'll go back to shape 21, and then theme minimal just gets rid of the grey default background that we have otherwise with ggplot. And then we can also make the text a little bit bigger. So theme minimal has got a really nice base size argument that you can use to control the size of your text in the graph as a whole. So that's the default, and that's it with base size 16. So it's looking a little bit more readable. I appreciate it's probably still quite small on the screen, but we're getting somewhere. I'm then going to move the legend to the bottom of the plot. We're going to get rid of it in a minute anyway, but it was taking up so much space on the side that the dots were all pretty cramped together. So I've moved the legend out of the way. And then there we go. So that's our first graph. Hopefully it makes sense and everyone is still with me. Let me just grab the code that corresponds to that. And if you want to give it a go, you can find the code just here. So if you go to what I've just posted in the chat, they're just there, you should get both the data frame that we're working from and then this basic plot. Some of you might have come here with a plot that you're already working on, in which case that's great. You can use the tips that I'm sharing to modify your own plot. If you didn't come here with a plot that you're working on, then that's also okay. You can just use mine. So feel free to use whatever works best for you. And maybe you're working on a data story, but it's got nothing to do with penguins, but you also didn't bring a graph. Feel free to imagine that the data we're talking about is related to your story, because then you can make sure that you pick colors that are sensible for the stuff that you're talking about. And you might want to have a think about what text you would put as your title and so on and so forth. So yeah, however you find it useful to interact with the code, go for it. And if you get stuck on anything, give us a shout. Hopefully that's everybody up to speed with our first graph. As I said, you'll need to install the Palmer Penguins package and you'll need to install ggplot and dplyr. So you might as well install the tidyverse, which installs everything. Let me just pop that in here. I feel like most people will already have the tidyverse installed, but just in case, this is how we do it. Oh, there we go. Okay, so we have our starting point. Now we need to optimize it because it's, it's fine, it's functional, but we can make it so much better. So we're going to do colors, text, and annotations. This is the stuff that I talk about all the time. So this is going to be the quick version. If you want to really nerd out on this stuff, you can find plenty of other resources on my website to do that. But I just want to get us to a point where we've got something that we're happy with, so that we can then iterate on that. So colors. The tip that I'm going to share today is to try to pick colors that, yes, Peter, you're asking about splitting the penguin species names. We will come to that with 2 options for you. So look out for that later. So in terms of picking our colors for our penguins, I tend to encourage people to try to come up with colors that are meaningful and sensible for the stuff they're talking about. Penguins are all a variation on black, white, and probably a bit of yellow somewhere. So not super helpful if we want to look at our different species. But what I suggest we do instead is we use a colour that starts with the same letter as the species that we are depicting. So if you will allow me amber for the Adelies, and cherry blossom pink for the chin straps, and green for the genties, then we have our three colors here. So have a think about your own data stories, if there are any colors there that you think you could make use of. And the trouble with doing that is that sometimes you end up with colors that just don't look nice together. So my top tip for managing that is to blend in a common color across the colors that you have used. And it's a trick that's used quite a lot. Those of you who have small kids or who interact with small kids, if you get the paints out, it gets really messy. But actually, the colors that they produce are often quite fun because they're messy. Different bits of different colors end up blending into each other. So you end up with something that actually doesn't look too terrible, even though they didn't really necessarily aim for that, which is fun. So I ended up creating an app to allow us to do this. You can download Monochroma as an R package. You can just install it from CRAN very easily. Or you can use the Shiny app. So this is what I'm hoping will launch in the window here. There we go. Can we all see the please wait thing loading? Yeah, we've got the app up and running. Great. So initially I created it so that you could do stuff like this. So start with dark green and say I need 9 colors, and then it would give you 9 colors that come from the dark green, and they always retain a little bit of the starting color at the end, which is quite fun. But actually the way that I ended up using it a lot more recently is to blend in that common color. So let's say we've got the orange color of our penguins, and then I know the hex code for my brand color. I just need to add the hex in front, is this. So this was the starting amber color that we had. And then what we can do is blend in as much or as little as the overall brand color as we want. So obviously if you've got a very dark brand color and you've got a light color that you're working with, you're probably going to want to blend in a little bit less of it. So I think I landed on blending in about 5%. And then you've got the pink color that we used for the cherry blossoms. So again, if there's nothing there, it looks like this. If we blend in too much of the blue, it kind of goes to blue or heads towards the purple. So you can kind of play around with different bits of it. And then we had the dark green for the genties. With the dark green, we can probably afford to blend in a little bit more because it still stays green. So it's a useful, I found it a very useful tool. And I think the fun thing is that then it does make color palettes where the colors look quite nice together. So if we go back and show, this was the original, this is the updated one, it's pretty subtle, the difference between the two. But it means that if I'm showing this alongside my brand colors, I know it's going to work. It reduces the clash a little bit, and it means that your colors just look a little bit more muted, which is also helpful from an accessibility point of view to not have colors that are too in your face, basically, for people. So what I'm going to do is I'm going to copy the link into the chat. And if you would like to, you can have a play around and think of your colors. So let me just show you what it does because it's pretty subtle. So here's the original. Here it is with them changed ever so slightly. You can barely notice it. And then I'm going to add also my brand color as the contour of the dots just to bring everything into some kind of unified sense. So, before I let you loose on your colours, just one thing that came up in a workshop recently. There we go, the sun's stopped shining straight at me from my window. One of the participants said, how come I've made bee-swarm plots and jitter plots before, but they don't look anything like yours. So what are you doing to make these work? And a lot of it, I think, comes from my background in psychology and visual perception, and that using these principles of the Gestalt principles of how we perceive elements as belonging with each other. So the law of similarity, if things are the same color, we tend to perceive them as being part of the same piece of information. Proximity is what we were playing with mostly when I encouraged you to restrict the jitter on the dots so that they were very clearly all part of the same band. So we're playing with proximity. And we're also playing with, do things just merge into one blob, or do we still see them as distinct shapes? And I think having things that come in, if you put contours around your dots, let me just go back to the graph. And if we didn't have the darker contours around these orange dots, then they would all just merge into one blob. Whereas because we've got the contours on, we can see the individual penguins. So that's probably the tip there. Use contours well, control the jitter that's going on, and that should give you that nice compromise of showing individual data, but without it looking like a bit of a mess, which can very easily happen otherwise. So have a think about your own research context, about your own data that you're working on. What would be sensible colours for you to be thinking about? What colour do you need to blend in? So do you have a brand colour that you need to stick to? This is the way to make your marketing department not get upset with the different colours that you've chosen in your visualization, by the way. If you show them that you've considered how to make it work with the main brand colour, then that's always helpful. So what colour do you need to blend in? Or maybe just pick one of the colours and blend it into those that are there. Yeah, have a go at the Monochroma app and see what your colours look like. I will put the link to this as a resource later as well. But I don't know if any of you are playing around with Monochroma, give me a quick thumbs up so I can see what's going on. But it's always hard to see on these meetings when there's loads and loads of people. Oh, good. A few thumbs up. Excellent. I hope it's working for you. Looks like it is. Is anyone stuck? Does anyone want to put a help message in the chat? Or I think we're probably okay. Good. Good stuff. Okay, so yeah, hopefully that will unblock a few things for you in terms of colors, in terms of making them work well together. And then we can set about applying them to our graphs in fairly sensible ways. So we've optimized the colors. We're going to optimize the text. So do we need the legend? We don't. We don't need it anymore because the color is the same thing as what's on the axis. So because these are the adelies and it says adeli here, there's no point in also saying, oh, by the way, the adelies are the yellow ones because we know that it's all here. So we're going to get rid of that by using legend position equals none. And then we're going to get rid of the axis titles as well. Yeah, so there's a good question in the chat about what about the body mass of the penguins. I have chosen to kind of ignore that and use it as noise to jitter. What I would probably do, because the body mass isn't the main thing I'm interested in here, I would probably add a subtitle to the graph, just say, the bigger the dot, the bigger the penguin. But yeah, that would be your call if you wanted to put the legend underneath the graph and include that in. That's not a problem. You can use the guides argument of ggplot to control which one you report. So you might want to just include the size in the legend, or you might want to just include the color. If you use the guides option, that'll get you there. So I'm going to get rid of the axis titles as well, because we know that these are species, and also beak length we're going to pop in the title, so we don't need to pop that down here. So that already is getting rid of quite a lot of text in our graph. Here we go, we've got the title back in. I've not gone very imaginative with this one. That's okay, we can come back to that. So beak length by species. And then we're going to be helpful to people. So we are going to create ourselves a tiny little function down here, which takes x and pastes millimeter next to it. And we can apply that to our x-axis. So instead of just saying 40, it now says 40 millimeters and 50 millimeters and 60 millimeters. It's just quite an easy way of adding your unit in such a way that it's helpful for your readers to know what they're looking at without you having to rewrite anything in your data. So the label equals function is quite a flexible thing that allows you to do quite a lot there. So there we go. Peter asked about the y-axis. So the names of the penguin species. We've got, chinstrap penguin, and then the Latin name that corresponds to that. We don't really need that in our graph. You could maybe add that in the text if you really wanted people to be finding out the Latin names of your penguins. So we've got two options. One is to do the same thing again. So we can create a function. Here I'm just using regular expressions to do this. So satisfying when you get your regular expression right the first time around. I felt like I needed to point that out. So we're saying everything up to a space and then anything after it, we're going to replace with the contents of the first brackets. So instead of these three bits coming back out, we're just wanting the first one coming back out. And then that gives us just the first word of each of the penguin species, which is very handy that they were all the same. So that's method number one, and I can see that Curtis is with me on getting your regular expressions right on the first go without AI. Yay! Let's keep ourselves nimble. So we've got we can do that as option number one. The trouble with doing that is that I know I'm going to want to do stuff like print the species into a label at some point in the future. And so what I'm going to suggest we do instead is actually mutate it in the data. So it's the same regular expression that I'm using. It just means that now within the data, the species column just has the short word for the species. So there we go. We've sorted out a few things. One thing that we haven't touched on is text hierarchy. So text hierarchy, if you've seen a talk by me before, you'll have seen something about this. So much easier to demonstrate than it is to explain. But I haven't yet met anyone who disagreed with what this slide was telling them. So the way that we format our text guides us as to what we're looking at first, what's most important, what we might just come back to at some point in the future if we want to, but we don't really have to, it's not essential. So as dataviz creators, we need to harness this to make sure that the visualizations that we're creating are ones that will help us guide the readers to the most important parts of the text to read. Part of this is just down to the fact that if you see text on the screen, you're just going to read it. We can't stop ourselves from reading text. So having something like this in our graph means that people can see exactly where they should be looking. So the first thing I'm going to do to improve the text beyond changing the content, which is what we've just done, is to add a bit of personality to it. So I'm changing the font of the graph as a whole to work sans, and then I'm overriding that to be Poppins in the title. So we've got two different fonts on the go there to make that work. I'm then going to make the title bold and also increase its size. And again, that just helps it stand out compared to the rest of the text that's in the graph, which is more kind of auxiliary to help us make sense of it. So there are different ways of doing this in terms of text. In terms of sizes, you can hard code your text sizes. The better approach is to use relative text sizing, because if you decide that then you want to change the text as a whole, if you've written the text sizes in as relative, they will all adapt to the new size that you put in. So the relative size here feeds off the base text size that we've got here. So it's basically saying instead of using just 24, which was hard coded, what we're going to do is we're going to say 16 times 1.5, which is also 24. And that will allow us to have a graph in which the text size is all relative to each other, and so it will adapt nicely as we go. We also want to change the text color. So I've made it red here so that we can see what's going on. This was a bit of a surprise to me when I first started playing around with different text colors. You've said to make all the text to be red, and yet somehow this text is not red. So what's going on? What's going on here? What's going on here is that we have got theme minimal as part of our code. So we are going via theme minimal and then modifying stuff. So you can see theme minimal just here. And theme minimal has already said what the axis text colors should be. So we need to go in and override that in our new theme. So we say axis text, here we're saying red. We're not going to keep it red, but it just shows you what's going on. And by doing that, we are able to change the size of it. So there we go, we've got the axis text sorted. I'm going to change it to a nicer color, which again is aligned with that dark blue that I use a lot. And I've also changed the title color to be an even darker blue. So we've got a slightly darker color for the title, slightly lighter color for the rest of the text. And that's how we change the colors of the text that we're using. So I'm going to share with you another code gist for you to use, which is one in which we've done some of this styling. And what I would encourage you to do is have a little bit of a play around with it. So there's the link to the code. In order to play with fonts in R, you will need to install system fonts, which is a package which helps you manage all your fonts. There's been lots of different schools of thought over the past, but system fonts seems to be where people are landing in terms of good font management. And it works really well. I have written a whole blog post on getting fonts to work in R, which I'll include as a resource on the website, because it can be really tricky. But if you've got system fonts set up, then that's a good part of the battle won. What you can then do is use system fonts, and then view, and that will allow you to see which fonts you already have installed on your device. So that should bring up a data frame for you, and then you can see which fonts you've got. Some of you will have lots of fonts if you enjoy playing around with fonts. Some of you will have fewer fonts, and that's fine. I don't have time to go into how to install a new font, but what this allows you to do is see what fonts you've already got available to yourself. And what I would really quite like you to do is pick a font that you can see that's installed on your device and try to change the fonts that I have put in the code that I've shared. Is everybody clear on that? So we've got the code that I've shared in the chat here. You can have a look at what fonts you've got installed on your system and have a go and see if you can create a plot that has got a slightly different font in it. Go for something wild, if you've got Comic Sans or Impact or something, then it'll at least allow you to see whether it's working. If R can't find your font, it will default to the default ggplot font. So again, there's stuff in that blog post about how to get that to work if you get stuck. But it's a worthwhile exercise. Just it allows you to move away from the defaults, which is quite fun. And if you've managed to do that or given that a go, you can also have a go at changing the text color in the graph and try to re-render that and see where you land. Has anyone managed to do that while I was talking at you? Let's see. Any thumbs up? Lots of concentration. I'm going to assume lots of concentration. Oh, Milena, well done. We have a thumbs up. Excellent. Yes, 2 thumbs up. This is good. Yep, from Kinga. Excellent. You have an error with system fonts. Okay. Yes. So Martina has just highlighted the issue that sometimes you can get on Windows. If you are on a Windows device, what you need to, there are several things that you need to do. One, when you're installing a font, you need to make it available to all users. So you need to install for all users. The other thing that you need to do is in RStudio, if you're using RStudio, go to your global options. And within your options, you will find a way to change your graphics device to AGG. So you want to change your graphics device to AGG, and that will allow it to all play nicely with system fonts. You might also need to check what your computer is calling the font. So when you did system fonts view, there's the font name and then there's the font family. And so you need to use the family as you try to import that into the plot. So hopefully, Martina, you've I was going to say you've shouted yes, but I don't know whether that's the right way to say it. You've all capsed yes into the chat. So, okay, so that was the RStudio setting. Okay, so yeah, setting your RStudio graphics device to AGG is the way to go, and that will help you. Those of you who are on a Mac, I had an issue that there was a font that wasn't validated, and so that was causing me problems. So yeah, there we go. Konstantin, you've got a question. Why am I defining the aesthetics in Jitter and not in ggplot? Yeah, I will change that later. I like sometimes, if you're using annotations, sometimes it's helpful to have the aesthetics defined in different sections of it. So you might want the points to be about the whole data set, and you might want the labels to be about a subset of the data. So we'll come back to that in a bit. Hopefully that answers your question. Yep. Okay, and one of you is having a problem with work sans, so you need to check whether work sans is actually installed on your computer or not, because it might not be. It's not one of the default fonts. So try getting your graph to work with a font that you can see is already installed on your device, and that should get you out of that situation. You can get work sans from Google Fonts otherwise. You're welcome. Okay, great. So that sounds like people are making progress and giving it a go, which is good. We can optimize some really small things. So we can change things like the background color. We can change the line color here. I've made it white. I've made the background this kind of pale gray. I've changed the size of the caption. I don't have a caption, so I'm not quite sure why I've done that. What I have done is I have used a plot margin just to give everything a little bit more space to breathe. So we've optimized the small things that nobody really normally looks at, and we've got ourselves a nice looking plot. Now, I promised that I would give you some tips for making life easier for your future selves. And that's exactly what we're going to do. So we can turn all of that styling, so all of this code that starts here and goes to the end, we can start that, we can use that, and you can turn all of that into a function. So what we're doing here, we've got our plot, and then we're saying plot plus theme minimal plus, and all these different theming items that we have just spent a bit of time thinking about. What we can do is turn it into a function. So we're going to call it theme beak-off, just to stay on topic. And our function essentially just encases all of the code that we've just written. Now, there is a slightly different thing that we can do here, which is to put the base text size as an argument for our function. So this means that we can very easily change the base text size if we want to when we're creating a different plot. So we have theme beak-off with a base text size of 16. So that will do the job nicely. Glenda's asking for the link to the slides. There's no link to the slides just yet, but I can share the link to the code. The slides will be on my website first thing tomorrow morning. So we've got this, we've turned it into a function, and now we can apply that to any graph that we want to apply it to. So completely different graph, not stuff that we've been talking about before, but we've got the theme beak-off at the bottom of it, and then that's going to work nicely. We've got our different graphs coming out. So you can see that these are both styled exactly how we've said that the previous graph should be styled. And this is something I highly recommend you doing, those of you who are creating lots of visualizations in your own work, to create your own theme, because then you can either set it at the start of a document, or you can just reuse it wherever you can, and it will make everything look like it's nice and consistent and come all from the same place. Something that I really enjoy doing for clients. So if that's something that sounds interesting, that you don't want to do the heavy lifting yourself, come and chat. That's absolutely fine. But hopefully here I'm giving you at least a good starting point so that you can continue to adapt it so that it fits the brand guidelines that you need to stick to. And here we go. So here I'm demonstrating, because we've given it the base text size argument, we can make the text much smaller if we want to, or we can make the text much bigger if we want to in another graph. All of that without making really any changes to our code. We're just changing the base text size here, and it does the job. You'll notice that I added a little sneaky line break in on this one. The text was going off the side. There are other ways of managing that, but we don't have time to go into that today. So we've got a theme, which works nicely. So I am going to share the third code snippet just now for you, and encourage you to have a go. So what this code snippet contains is the theme beak-off theme that I've just shared. It's essentially the stuff that was at the bottom of the previous plot that you've created, but what it allows you to do is have a theme, and then you can apply that to a completely different plot if you want to. So grab the theme and change something random, like the color of the background, or maybe the size of the text, how the relative size, and see what you can do, and try to apply it to a completely different graph. If you're wanting some code for a different graph, I'll just pinch the stuff that's here. This is going to be ugly in the chat, but it's there if you want it. And that will allow you to see just how much easier you can make life for yourself. And the beauty of this is that if suddenly you have a rebrand and you need to change the font across all of your graphs, you only have to change it in one place, and then your theme will carry that through. Otherwise, if you're copy pasting these chunks of theming everywhere, you're going to have to change the font in all of those different places, which will be a bit of a nightmare, I would say. Has anyone managed to create a new graph using the theme function? I appreciate throwing a lot of information at you, but that's okay. We're nearly an hour in, so we're doing pretty well. We will talk about parameterization. Do not fear. We will get there. Good stuff. Martin has just copied and pasted. I hope that has worked for you. It's always good to just check these kind of things in different environments, but it should do the trick. Okay, so that's where we are. We've been trying to make things helpful for our future selves. Now we're going to do the fun stuff of adding in some annotations, and we're going to add them in such a way that they should respond to the data that we're feeding it. So we want to show the main story, which is the range of the beak lengths that we have in each team. That's the important thing. We also wanted to look at the means within each group, just to see are they roughly representative of the overall population. And we're going to make the title programmatic so that the title adapts to the content of the graph. So here is our starting point. This is where we were just before I shared the latest bit of code with you. What I'm going to do is grab the minimum and the maximum beak lengths in our overall data. So we're feeding in the data, we're cleaning up the species names as we did earlier, and then I'm saying filter it so that the beak length is either the maximum or the minimum in the dataset. If you're doing this kind of stuff, make sure you remove any NAs. We've already got rid of them earlier, but if just in case, if you're working with data where you're not sure where the NAs lie, otherwise you end up with some pretty interesting annotations going on. So get your NAs to be removed while you're doing that. So we've got some fresh data, which then we can feed into these vertical lines here, which are showing us what the smallest beak and the largest beak are in the data that we're looking at. Everyone with me on what we've done here? I'm going to take that as a yes. So we've taken a subset of the data, we're feeding that into the graph. I'm going to move that so that the graph is behind, so the lines are behind the dot. It's easier to see if I zoom in because we want the dots to be at the front and the lines to be behind those. So the way to do that is simply to make sure that you plot your lines before you plot your dots. Fairly straightforward. So we've got that sorted. I've made them a color that ties in with the text colors that we're using. And then we're going to add some labels in. So again, this to answer Konstantin's question from earlier, this is why I was defining the aesthetics within the geom jitter, is because I want different aesthetics here for my label. We've got these. Actually, did I do that? No, you're right. I did. I redefined them at the top. So I redefined the aesthetics here because the common length and the species are aesthetics that we want to keep constant, but we need to make sure that we're defining a label as well within the annotations here. So with the data that we're using is not the overall data, it's just that data that's subset to the minimum and the maximum. And then we're using the label common length in millimeters and pasting that in. And you can see the label here. The one over here has gone off the edge of the plot. So we'll sort that out in just a minute. But we've got some annotations which highlight the story that we're looking at. I'm going to style the annotations a little bit. So I've changed the font so it matches everything else. I've changed the alignment so we can actually see them there. I've changed the color and I've got rid of the white background of the box. And again, I'm just leaving some things in so that we can see what we're doing. But we've now got two labels that sit in exactly the right place, just straight from the data, which is helpful. I've decided that I'm actually going to move the labels to be at the very top of the graph. So we're going to plot them so that the y coordinate is the maximum of the species, which is what we've got here. It just does it in alphabetical order. So they're above the gentus, and then I'm nudging it so that it's out of the way, which is quite a useful nudge. I kind of found this out while I was working on this talk, because these are categorical labels. It's quite difficult to be very precise with where you want things to land, but the nudging is your friend here if you want to move things about a little bit. So you can nudge even on categorical variables, you can nudge it, and 0.33 kind of takes it a third above where the different limits are of the different categorical variables. Does that still make sense to everyone? Hopefully it does. So we've got some labels, we've moved them out of the way, and the nudge is a really helpful one in doing that. The next thing that I want to do is just make sure that I'm aligning them sensibly. So I want to make sure that the one that's the minimum is kind of butting up to the line that way, and the one that's maximum is butting up to the line that way. I'm really bad at left and right, so you'll just have to interpret this way and that way from what I said. But we can see here that it just helps us see what they correspond to, and they're nicely aligned, which is really good. This is done with a bit of conditional alignment, which I always encourage people to do for these kind of things. So we're saying that when the length is the minimum length, we're going to align it 0, and when it's not, we're aligning it 1. And that's the justification of the text, and that's the alignment. So hjust, I think, controls where the label as a whole sits, and halign controls where the text sits within the label. One of the reasons why I'm sticking to ggtext for now rather than moving to marquee is that marquee doesn't quite allow us to do this as easily. So those of you who are on the marquee bandwagon, excellent. I've also been exploring it and it's been good fun, but I'm still sticking with ggtext for this kind of work. So we've got the labels aligned just the way that we want them to be, which is good, and everything's looking neat. I'm going to make them bold and change the color of them a little bit. And then I'm also going to add in these little arrows. So this is just Unicode, which you can paste in. And this means, again, the label is conditional. So when it's the minimum one, I'm pasting this arrow and then the length. But when it's the maximum one, I'm pasting the length and then the arrow that goes the other way. So you can do some quite neat stuff using the case when argument, the case when function from dplyr to get your annotations to look just the way that you want them to. Then I'm going to get rid of the box and remove the padding so that the text falls exactly onto the line, which is where we want it to be. And there we've got ourselves some nice boxes that are sitting just where we need them, but we can't see the box anywhere, we just see the text and it's highlighting those lines, which is useful. So we've nudged things, we've got the text out of the way, I figured out how to do that, so there we go. What else did I think we could improve on this? Well, yes, we can add a bit more data. So I'm not going to go through this step by step because I think we'll end up spending too much time on that otherwise. But it's exactly the same principles going on here. So what I've done is I've taken the means, the mean beak lengths within each species. and done the same thing. So we've tidied up the data a little bit, and we've got the species, we've grouped by species, and then we're summarizing it to get a mean length within each species. So that's us all sorted. We've got our data, and now we can feed that through into a label. So the geom text box here, and that works nicely. And then I've also added, what have I added? I've added these little dotted lines that show us the mean that's going here. So we have a question in the chat here about why this isn't a box plot, and this is a very good question. So box plots are fun. So some people love box plots, some people hate box plots. I find if you push people hard enough to explain what's going on in a box plot, people fall apart at different points in that explanation. So the line in the middle we know is the median, not the mean. The outsides of the box are the 25th and the 75th centile. Then you've got the whiskers that stick out, which are everything other than the outliers, and then you've got the outliers sitting at the end, which are typically stars or dots that are outside the whiskers. The box plots are good if you're trying to highlight statistical outliers, but sometimes they're also not really practical outliers. So you might have quite a few penguins that are all grouped together towards the extremities, and one of them will be highlighted as an outlier and the other two won't, just because of where they fall within the distribution. I appreciate there's scientific validity behind that, but sometimes for helping people grasp the stories behind the data, then people find it easier if they're seeing the actual data than if they're seeing a box plot and having to imagine what the cloud of data looks like behind that. So yeah, it's a preference. So people use different things for different scenarios. If you're in a field where people are using box plots all the time, then go for a box plot. But if you're looking to engage with the general public who don't understand box plots all the time, then something like this I find is much more accessible. And it also allows you to do other fun things, which we'll do in a bit, which, you can color code things differently or you can group things differently. It's just a bit more flexible than a box plot. So that's my little box plot soapbox over, but hopefully that made sense of your question here. So we've got the means, we've got some annotations in here, and we've got a graph that kind of highlights the information that we needed to highlight, which is good. And we can now get rid of the y-axis because we've got it labeled here. So we don't need us to say this is Gentoo because we're saying it's the Gentoo mean, here is the Chinstrap mean, here it's the Adeli mean. Again, different fields will have very different takes on what's acceptable to get rid of in an axis. I tend to try and minimize the text as much as I can without losing the story. So this is, I feel we don't need the axes here because it's just going to repeat what's in the graph. The direct labeling approach is just a little bit kinder for people not having to jump around between the axis and the content of the graph. So there we go. I promised you some interactivity in the abstract of the talk, and then thought, oh no, I need to do this. But actually, it's so much easier. It's easier than you think. So I'm going to show you what we need to do. All we need to do, we're creating an interactive version of our plot. Instead of geom jitter, we're using the ggiraf package or ggiraf. We can all have a discussion on how it should be pronounced. So I'm going to call it ggiraf. So I use this package because I find that it's the most faithful to the way that I've styled the plot. So there are other options. Some of them have got licensing fees to them, some of them haven't. Plotly is another one that people tend to use. I find Plotly sometimes rearranges the text a little bit or changes the background or does something that I'm just like, no, I've thought a lot about what I want this to look like. Please leave it as it was. And I find that this package for me does that really nicely. So all we need to do is change our geom jitter to ggiraf geom jitter interactive. We then need to give it something to pop in the tooltip, otherwise we're going to get stuck. So we're going to give it, we want to print the individual ID, so that's the ID of the penguin, and we're going to say what island they're from. So if you imagine it in the voice of the gladiators presenter telling you this is penguin so and so from such and such an island, then that will keep us all entertained. And then once we've done that, we've got an interactive graph. See, that was it. So it's so much easier to do than people think it is. And hopefully having some of the code from here today will allow you to do this as well. It works, then you can embed it in HTML presentations, which is what this is. Or you can export it and embed it in a website, and you've got it all there. So here we go. This was the one from Bisco, which a few of us have chatted about a few times. The big Bisco penguin, he kind of stands out on all of the metrics that we have. So we've got ggiraffe or ggiraffe, however you want to call it, sorted, and we've got an interactive plot, which is really nice. In doing so we've created the plot, and then we just feed it into the ggiraffe function, which is why I called it ggiraffe, because I think then there's the giraffe thing inside it. Anyway, it doesn't matter. So we've got that function which does that, but we also need to style the tooltip. So here it's a bit zoomed in, but what you can see is the tooltip gets styled with some CSS. So if you can read the CSS, we're changing the background color, we're changing the color of the text, we're putting a bit of padding around it, spacing out the letters, giving it a bit of space to breathe, basically. And then we've also put our font in, so that then when we hover over it, we're seeing everything styled the way that it should be. So there we go. You've made an interactive graph, and it's not as difficult as we think. And the beauty of it being all with CSS as well is that you can then quite easily Google how to modify things. So we have a graph, and we spent a lot of time on it, and now it's time to test it out as a function and see how we're going to get on. So here is the full code that we have for our graph. It's quite a lot of the code. So if your colleague comes along and says, actually, can we just do the first 200 penguins instead? Then you can copy paste all of this and go again. Or you can turn it into a function so that you can just say, I just want the first 200, and that will make your life a lot easier. So what we're going to do, it just all happens here in this line. Oops. Oh, yes, the back button works. So all we're going to do is happens in this line here, where we've got our function definition. So we are defining a function which takes as an argument df, short for data frame. You can call this whatever you want to call it. And we're going to say that by default, df is the penguin data frame that we've been working on. And then we encase everything inside one curly bracket here, one curly bracket at the end. And we have made ourselves a nice little function. So let's just check it works. It does. So here are two different plots, both created from this function. And we can see in this one, we have taken the first 200 penguins in our data. Oh, we've sampled for 200. And here we have sampled for, oops, where's that going? There we go. We've sampled for 100. So there are far fewer penguins on this side, as you can see, than there are on this side. But the annotations are mostly in the right place. We'll fix this one in a minute. But the annotations are mostly in the right place. The means are all adapted in the right place. The colors are all staying consistent. And we've created two different plots with just 2 lines of code, rather than copying what I think is ending up around 80 or 90 lines otherwise. So we made a function and it works, and we can do it again. We can take a different sample and run it again. So there are ways in which we're going to improve on this function, and I will share with you the final code as we go. We're going to let the beak-off begin and let the penguins choose and organize themselves into teams. But we've been going for over an hour, and so I suggest at this point we take a 15-minute break, and then we'll come back and do, see how we can improve on this. We have already parameterized it just for the data, but we'll parameterize it much further after that. So we'll let the beak-off begin after a break. So let's take 15 minutes just now. Back at 5:02, and we'll resume with the rest of the talk. If anyone has any questions, I will stick around. Otherwise, see you in a bit. Okay, so we are back from the break. And actually, I made a mistake during the session. I forgot to unclick the pause recording. So I'm re-recording the second half of our workshop. But I will do my best to remember what people asked, what came up, and include that in the chat here. So apologies if this feels slightly different to what you're expecting. But let me share my screen and we can crack on with what we did. So before the break, just to recap, we created a function which allowed us to create different graphs with different data sets, but the annotations all landed in the right place. And there's a few things that you can see that we need to go and fix. So for example, these annotations are not where they need to be. And there's a few bells and whistles that we're going to keep adding to our graph as we go. So our function does work, but there's more that we can do to make it better. So let the penguin beak-off begin, and we'll get them organized into different teams and plot what's going on and see what we need to amend to make it all work nicely. So the first thing that I thought we should do is add an argument to our function that allows us to print the team name in the title of the plot. And this would be quite useful if we then wanted to go back over our plots and find the winning team. If you'll remember, the winning team is the one with the biggest range of beak lengths in the data. So we're going to add an argument called team name to the plot function, which we can then paste into the title. So then the title will say team and then the name that we've just given them. So let's try that here. So here we've got Team Penguin-tastic and here Team Jollybeaks. I wasn't being particularly creative with my team names, but since this is what we're talking about in the realm of penguins, it seemed to make sense. So you can see we've got our make beak-off plot function. We've added the team name argument to it, and then that is bringing the team name straight into the title, which is a nice little extra touch. One thing that we noted earlier was that the maximum, the annotations that show us the range, they were kind of not at the top, which was what we'd fixed in the first half of this session. So we need to figure out what's going on. It actually took me longer to figure this out than I would like to admit. But what's going on is that at the start, we're reading in the penguin data frame, and then we are creating the beak range data frame, which is a subset of the total. And so for this one, we're taking the minimum beak length and the maximum beak length, and we're just filtering to that. And this is why the annotations are jumping around, is because the minimum and the maximum might not correspond to, they might not include the species which is in the graph at the top when we look at the penguins as a whole. So at the top, we've got the gentoo, I think, in the graph. If one of the penguin with the maximum beak length and the minimum beak length were not gentoos, then the annotations are going to go for the maximum of the penguins that are included in this subset. So we need to fix that simply by saying that the y coordinate for this text box should be the maximum of the overall species of the overall data frame. So that's the penguin data frame as a whole, not the maximum species within the frame that corresponds to its own data. Slightly confusing, probably why it took a while, but we got there. And so once we fix that, we can recreate our plots and we can see that now it did work. So where previously the annotation had ended up down here, because the maximum penguin was a chin strap, here we've got it still nicely at the top of the plot, which is exactly what we had wanted to do. So that's a win. Excellent. The next thing we could maybe do is add the range into the title so that when we're comparing the graphs, we can see the team name and also the range of the beaks, because that's the winning criterion. So let's go and read that in. So here we're taking the maximum beak length from that little data frame that we've got and the minimum. We've already excluded the NAs at the point of creating that data frame, so we don't need to worry about them too much. And this allows us to create a title which includes the team name and the range of the beaks. We're adding the unit in there just to be helpful. Let's give that a go. So here we have the penguins, and here we see if we take this random sample of 20 of them, we've got their range nicely printed here. If we take this sample of 50 of them, then we've got the range printed nicely here as well. So there's a few other things that I think it would be worth us considering. One is that it's actually quite difficult. I mean, fair enough, 23 and 25, not hugely different, but it is quite difficult to see that they're any different because the axes are adapting themselves to the data that we're feeding in. So we need to figure out how we can fix that. We'll also think about the colors, and then there's a few styling things that we can do to make sure that it still always looks nice. So as you can see, this kind of illustrates what's going on with the range. Here we've got an axis that's going kind of above the 50. Here we've got an axis that stops before the 50mm mark, but it kind of gets stretched out to the same extent. So we need to figure out how we can make this comparable. Now, depending on the kind of data that you're working with and the types of stories that you're looking to tell, you might want to actually stick with a consistent you might want the axes to modify. So if what you're interested in is looking at the detail within each of the groups that you're plotting, then maybe having the axis limits adapt to those groups is the right thing to do. And in our case, we want to compare the teams to each other. So we need something to stay stable so that the different graphs will look different if the range is different in them. So we need to try and figure that out. So the way that we're going to do it here is simply to use the limits argument of the scale x continuous function. So here I've hard-coded them, and I've hard-coded the limits to what I know to be the minimum and the maximum within the whole data set of the penguins. If we don't do that, the trouble is that we're going to end up just taking the limits of the data set that we're feeding in, which is exactly what we don't want to do. So we're going to hard code it here. What you could do if you wanted to be a little bit more clever than I've been is feed in the whole data set at the start and then do some subsetting using some other arguments in your function. And then that would mean that, for example, if you wanted to run your data on the hamster data set rather than the penguin data set, then it would be consistent with the overall hamsters rather than the overall penguins. There's different ways of managing this. In this case, it was easier for me to just do it this way, but you'd have to use your own judgment again as to how parameterized you want your function to be across different permutations that you might try and send its way. So here we can see it does the job nicely. That the penguins here are looking a little bit more squished together than the penguins that are here, which is exactly what we want. We want the graphs to look different so that they reflect the range of what's going on. I keep forgetting that the tooltips are there, but the tooltips are still here. So all of this is still interactive, which is very neat. Good. The other thing we want to do is make our colors stable. So if we had only had 2 species in our data set, then we might have run into trouble. So if you've got 2 colors, but you've fed it 3, so previously we'd said values equals this hex code, this hex code, and this hex code, so there are 3 colors to choose from. If we had given it a data set in which there were only chinstrap and gentoo, it would have still taken the first 2 colors. So we would have ended up with some orange chinstrap and some pink gentoo, which we know is not how we've set things up. So what we need to do is make sure that we feed the colors in with a named vector. This is something that I recommend doing whether you're parameterizing your plots or not. It'll save your own sanity, and it also saves you from that moment where you come back from holiday and your colleague goes, "Oh, I've been working on the stuff, but it turns out this should have been a factor, so I've just reordered it for you," and then suddenly your colors are just not matching the colors that you thought they should match. So I highly recommend doing this whenever you're adding your own colors to a visualization. Name them. So we're saying explicitly that the Adelie are this orange color, the chinstrap are this pink color, and the gentoo are this green color. And that means that regardless of how many species we end up with inside our graph, we will be able to be sure that the colors are going to be mapped correctly, which is good. So that worked nicely. So here we've only got 2 species of penguins. We've got the chinstrap and the gentoo, but it has nicely bypassed the Adelie color because we don't need it, and just use exactly the colors that we needed. So the colors are stable. That's all worked. So good, so we've stabilized the axes, we've stabilized the colors, we've stabilized where the annotations are landing. We're doing pretty great. So our plot works really nicely. It does all that we need for some iterations if we're going to be reporting on exactly the same thing all the time. But we can still got a bit of time ahead of ourselves, so we can add a few bells and whistles into it and see where we end up. So we might want to say that we want to check for male and female representation. We want the penguin teams to be pretty balanced. So in order to check for that, we're going to try and plot that as well. So at this point, you could create a whole new graph, copy paste stuff and just change what we're grouping things by. but that seems like a bit of a waste of effort, and there's a much better solution. So here we have the power of get. Now, the people that were in the workshop, they talked about the double curly brackets. That's another option to look into. I find them confusing, so I've gone with get, but do look up the double curly brackets as an alternative for doing this kind of stuff. So the way that I understand it is that it takes the string that you feed it and it interprets it as the object and returns the value of that object. So if I say that ice cream is my favorite food and then I get it to get favorite food as a string, it's going to actually return ice cream, which is quite neat. So then we can kind of essentially get it to, we can feed it things in string form that it can then retrieve the corresponding object for, which is nice. And we can escalate it a level. So we could say that favorite food is the question. And then if we say get question, it will read that. It will know that that corresponds to the string favorite food, and then it will interpret that as ice cream. So it's a little bit, it messes with your mind a little bit, but once you've played with it a few times, it sinks in. And this is really useful for us for our graph because it means that we can feed in different things. So we can say by default we're going to group it by species, but we might want to group it by something else. So I'm going to set up a new argument called grouping variable, and I'm going to set the default to species just so that we don't have to specify it every time if we don't want to. And then we can use get. So we can say that we're going to group by the grouping variable, which is species. So that means that it will group our data frame by species. Now, we still need to do something here, and it's a bit of a jiggery-pokery, but if you do run this, you'll find that you end up with a column name that is called this, get grouping variable, which is then quite difficult to manage with neocode. So I'm just going to rename that as group. But yeah, give that a go in your own console and see, you'll see what I mean, that you end up with a data frame that's got a funny name that then is quite difficult to rework. So we're going to rename that to call it group. And then we can just use this thing all the way through. So we can say, instead of the y-axis just being species, the y-axis is going to be whatever we feed it as the grouping variable. And this works really nicely. So here's our default, which is species. So we've grouped them by species, which is fine. Here we are grouping it by sex. So here we've got a few gremlins that have crept in that we'll need to fix. One of the gremlins is that we've got some NAs. So there are some penguins in the data set for whom we don't have any data so in terms of their sex. So we don't know if it's a male or a female penguin. So that's kind of getting in the way of where our labels are landing. And we've also got male and female in capital letters, which kind of stands out a bit from what we had done in the rest of our graph. So there's a couple of little bits and pieces that we need to fix in order for this to work nicely. So the first thing I'm going to do is I'm going to exclude the penguins for whom we have no data about whether they're male or female. So I'm just going to filter them out. You may take a different philosophical approach to NAs. This is just what I'm doing for the sake of demonstrating how we can tidy it up within the graph. So we're going to filter those out, which means that from the get-go, there's not going to be any NAs that are getting into the means, that are getting into the ranges of the beaks that we're looking at, which will make it easier to figure out where all the annotations need to sit. And then we're also going to, sorry, that's highlighted the wrong bit, but we're also going to make sure that the label is in sentence case. So it starts with a capital and then lowercase after that. So that means that when we run our labels, they should look the same as all the other labels have. This is quite useful if you're working on a data set in which different variables have been formatted slightly differently and you want to bring a bit of consistency in. Equally, use caution if you have a variable that needs to be all caps, then you might want to think about a little bit of case when going on here in terms of what you paste in, whether you paste it in as is, whether you tidy it up or not. This is all a question of playing around with your data and seeing what comes out the other end and what you need to tidy up in the process. So here we go, we've tidied everything up and it's looking a lot more sensible. So we've now got the labels landing in the right place, we've got rid of the NAs that were in the way, and the text is formatted in sentence case, which is what we needed. So that's great. Now, at some point in the competition, someone might say, okay, well, male-female representation, all well and good. I want to know that the islands are also well represented in each team of penguins that we're putting forward here for competing on the range of beaks that they've got. The excellent news here is that we've already dealt with all of this. So we can do that. That's fine. So we've already set up our grouping variable, and it doesn't have to be species or sex. It can also be island. So we've got the island grouping going on here, and we can see that we've got two different species of penguin on Dream. We've got the Adeles, we've got the chin straps. On Bisco, we've got the Adeles and the Gentus, and on Torgerson, we've just got the Adeles. So this comes back to the discussion that we had earlier about box plots and their accessibility. This is part of the reason why I like working with raw data and just showing it rather than showing the box plot summary, that you can do this kind of more fine-grained approach. So you can show that you've got a mix of different species. You can also show kind of which species was at the minimum and the maximum in this. And it's quite interesting that it's the same island that's winning, that's causing the range to be wide, which is quite nice. So if you had a box plot here, you would struggle to show some of that detail. You can obviously overlay dots on a box plot, but then it just gets quite confusing. So this to me is a more intuitive way of looking at the data than having maybe multiple box plots next to each other, which could then end up again being quite messy. So yeah, we've got our penguins here. We can just check that they're from the same island, which they are, which is nice. So yeah, everything's working the way that it should, and I think this is quite a nice accessible way of doing it. Now, obviously, because we're grouping by something different than what's on the y-axis, we might want to reinstate the legend. So that's something that we could quite easily do. We could add it into the function that if the grouping variable is not species, then we have a little extra, plus guides, specify which guides we want to add in and format those, and then reinstate the legend inside the theme. So that's all very doable. I haven't done it here, but would be interested to know how folks get on if you give it a go at home based on the code at the end of the session. This came up with one of my clients recently. I'd created a theme function for them, which was defaulting to a text size, which works well in presentations, but which didn't work quite so well in papers or vice versa. And they wanted to make sure that they could very easily go from one outlet to the other. It was already there, so the text size was already built in as an argument, but we added something to the documentation just to make it really clear to them that that's what they could do. So what I've done here is I've added a text size argument to our function, to the overall function, and then we can pass that through to our theme function, which sits inside it. So that means that we've got a text size that we can define at the very start, rather than having to change anything in our theme in terms of the default, and that can get quite messy. So let's give that a go. So here we've got the default text size, which is kind of 16 and then expanded. And here we've got a text size of 12 and then the relative text size of the title, which works nicely with it. So this is doing what it needs to do. The axes, unfortunately, are sitting underneath the edge there, but it does do what it needs to do in terms of making sure that the axis text and the title text respond to the argument that we've got inside the function. So we made the text smaller, we made it a variable. This also came up. So I was doing a workshop a couple of weeks ago, and someone talked about the fonts that we use, and would it be possible to have a theme in which you've got some fonts that work well for like a magazine setting or a presentation or public engagement, and another set of fonts that are more in line with what the journals, the academic journals are expecting. And the answer to that is yes, of course, we can do most things we can figure out how to do. So what we need to do here is parameterize our theme. So in the theme, we initially had said that the text was going to be work sans. Here what we're doing is we're giving it the base font argument, which we're defaulting to work sans, and then we can feed it through. And then the same with the title, we're giving it a title font, which means that then we can feed that through into the argument just here. So we've parameterized our theme, which we can demonstrate here. So here, remember earlier we created some completely different plots using that same theme. Here we've got them again, so you can see here it's styled default with pop-ins in the title, work sans down the side. Here we have styled it differently, so we've got Arial on the axes and we've got Times New Roman for the title. So you can see that it's different. That's because we've just parameterized our theme and just called them. This again is very useful if you want to keep everything consistent, but just have the option of changing your font. have a think about adding that kind of stuff to any bespoke themes that you're creating. Now we've done that in the theme. For it to work within our function, we also need to pass those arguments through to the theme that's inside it. So we're going to add the font options to the main overall plots function that we're working with, and then so we've got them in here, and then we can feed them in to the theme down here, and that should do the job. So here we've got our plot as we had it with the default fonts that we had set up earlier, and then here we've got the plot with the different fonts that we've just specified. So we've got Arial on the axes, and we've got Times New Roman for the title. At this point, it's worth having a bit of a closer look at this plot, because something's not quite right. So the annotations you will see are still using work sans, and that's because the font for the annotations is specified separately to the theme. So we need to go back in. The other thing that you'll notice is that the font for the tooltip is also still work sans. So again, if we want to parameterize things, we need to do it properly. So we'll go to those tiny details. So here we've got, for example, one of our text boxes. We're going to say that the family is the base font. So just replacing work sans with base font wherever we find it. And then we've also pasted it into, there we go, at the CSS here. So we've got the CSS code that's controlling how the tooltips are styled, and we can paste in the base font into the font family argument there. So we've got that all the way through the functions. So we've adapted not only the fonts that are inside the plot, the basic background of the plot, but also the fonts that are in the annotations and in the tooltips. So we've got all those tiny details sorted, and now we can see here we've got work sans in the tooltips and in the annotations, and here we've got Arial, just a slightly less rounded font. It's probably more visible on the letters than it is on the numbers actually, but you can see it there. And same for the tooltips here have Arial, whereas here they have work sans. Again, it's subtle, but this kind of makes all the difference between your plot looking polished, looking like everything is all together, and looking like you've just used some tooltip function that you found somewhere and copied over, which there's nothing wrong with doing, but you might as well style it while you're there. Finally, we might want to add something else. So you could, for example, change the background or change the border to highlight the team captain species. This is where this little magic trick comes into its own. So this is an ellipse, it's 3 dots. And what you can do is you can set that up as an extra argument in your function. And what this means is that you've then got this, essentially this wildcard that you can feed into your function at some point later. So I've decided that I want to have a bit of a wildcard that I can feed into the theme function. So it reappears just here. So we've got an extra bit of theming going on after our theme beak-off. We've got another theme to remove the axis text, because that's something that's specific to this plot that we don't necessarily want to do in the rest of our plots that are using that theme. But it also opens up this option for the wildcards. So let's show what that looks like. Oops, we've got it here. So here we can say, for example, make the panel background red. Not something that I think we should really do because it doesn't look nice, but it just shows you what you can do with it. Something that's a little bit more sensible maybe is to say, right, we'll take the plot background and we will give it a pink outline and we'll make the line width 5. And again, this just gives you a lot more flexibility with your functions. So once you've set it all up nicely, there might be something else that comes up. I had this happen with, again, a project with a client recently. I built them a reactable table, so an interactive table that it was a big function with lots of stuff happening inside. It was grabbing stuff from an API, it was cleaning some data, it was doing some conditional coloring, it was figuring out what to put in the legend according to what had been in the table. There was a whole bunch of stuff going on. But they realized afterwards that actually it would be helpful for them to be able to specify additional reactable arguments, such as whether it should be sorted or what it should be sorted by, or maybe sometimes they wanted it you know, with a zebra stripe or not. So what we did was we added that little wildcard into the top of the function, which then could pass into the reactable function, which means that then they could do a whole lot of extra stuff afterwards if they wanted to. So here we've done, you know, we fed it into the theme, so we're changing the background, we're changing the plot backgrounds. With the wildcard, you have to decide where you're going to put it inside the function. So you couldn't, for example, give this something that would fit, I don't know, within a different, you know, group by or something. It wouldn't be able to take the wildcard because you've specified that that should go into the theme. Equally, if you specified that you wanted to put it somewhere in grouping, you would run into difficulties if you then tried to feed it a theming argument. So you have to decide what it's going to be passed to, and then that will determine what you can use in it as a wildcard. But this does the trick nicely for what we want to do, and it gives us that little bit of extra flexibility. So there is so much more that we can do. For example, I mentioned reinstating the legend. You might want to have a go at playing around with that. So you've got your plot inside the function. What you would need to do is add an if element. So if the grouping by variable isn't species, then you want plot plus add in the guides, etc. You might want to have a play around with some conditional alignment for your mean labels. So it didn't really happen in the plots that I was looking at, but it might be the case that if you have a mean that's very close to the edge, the label will go off the side. So you might want to say, okay, well, if the mean is above 45, then it'll be aligned this way. If it's below 45, it'll be aligned the other way. And that will allow you to make sure that your annotations are always falling in the right place. You can do other stuff like adding an exporting element to your function so that you could, for example, export a file that contains your plot that also contains the team name. Maybe you would want to put the range as the first element and do some clever work with your text to make sure that when you're looking at them in the directory, they're all ordered by the range, and then you can see very easily who the winners are in our competition. You could maybe think, actually, I want to show them by species and by island at the same time. You can do that. You can create plots that are typed together with cowplot, and the interactivity works across the two, which is really quite fun. But yeah, at this point, what I really want to do is hand over to you, share the code. If you're rewatching this on my website, the code is in a link underneath. Otherwise, if you're in a workshop, I'll send it, or I've just sent it in the chat. And yeah, I think now's the time probably to workshop it, to see what else we could do, what you might want to try and do with it, if there's anything where you get stuck, and we'll take it from there. But thank you very much. Okay, so recording in progress at the very end. Let's workshop this parameterized plot function that we had and see where we end up with that. Does anyone have any suggestions of things that we should do slightly differently with it? There was a thing, I think someone talked about transparency. Yeah, we could add a bit of transparency to the dots. So that would just be within geom jitter. We could add a bit of alpha into that, which could be quite fun. Martina, you had something about the labels and how they could... Oh, okay, yes, I see what you mean. So you're talking about the labels and how the labels cross over the lines. I deliberately put some background color to the labels because I wanted us to be able to see them. So let me go back to, where are we? Let's find a slide that they're on. I'm trying to find one now where they overlap, which is harder to do. Yeah, because I wanted it to be really clear which label belonged to which group. Because every now and then, if they're overlapping, okay, I've got one here. So let me just share the screen just now. So if I share this, so here we've got a label which is overlapping with a line. And the label that's overlapping with the line, I made it deliberately not transparent because I didn't want the line to get in the way of us reading it. I think if we made that label transparent, then the line and could get in the way, and that would make it quite tricky for us to be able to figure out what's going on there. So yeah, that's the answer to that one. Oh, am I not sharing my screen? Sorry, I thought it was. There we go. So this is what I mean here. So we have our range that we were showcasing, and here we've got a label that sticks over the next line. I deliberately didn't make the labels transparent because I wanted us to be able to not have the text interfered with the rest of the information that's there. Hope that makes sense. I seem to have lost the chat. Let me see where you all are. Oops. Where have we gone? I'll stop sharing and find the chat again. Yeah, so that was that one. What else did we have? Yeah. Okay, Martina, I see what you mean. Okay, this is really helpful. So, yes, what you could do with that is change the width of the box. So you can make the width of the box so that it's much tighter around the text that's inside it, and that would probably avoid the problem. And you could also change the padding of the box to make that work nicely as well. Yeah, that makes sense. Very good. A few of you have said that you have to go. That's absolutely fine. Not a problem at all. Just keen to make the most of the time that we have and answer any further questions that we have. Has anyone tried to grab a different grouping variable and see what happens with that? Oh, there's a question here about types of plots that's harder to parameterize than others. I don't really know. I think to me, I feel like there's a lot of effort that goes into making a plot look nice. You know, if you're trying to create something really polished, and then parameterizing it is typically not a huge extra investment on top of that. So I think things that would be difficult to do, maybe if the data was kind of inconsistent and you weren't sure where you were going to end up with lots of NAs, where you were going to end up with complete data. That might make it quite difficult to do and to do it well. The other thing is if your ranges are jumping around quite a lot within the different subset groups, then you're going to struggle you'll struggle to know what to do in terms of your axis limits. So we need to make sure that we get sound decisions made on that basis. But is there any particular plot type that you had in mind? Feel free to unmute yourself and chat if that's easier.
Hey, Cara, thank you so much
Hi.
for the really nice presentation. This is the
Oh,
first
thank
time
you.
I've attended a workshop of yours. Really nicely done. So I don't have a particular plot in mind, but I often deal with a lot of time plots. So those are line plots usually. And they're not, I guess, that much more complicated than a scatter plot. But I can imagine like other time series, or if you're doing it's harder to control the look of, say, a facet if you're doing lots of little mini graphs together.
Yeah, if you're doing lots of mini graphs together, you'll probably want to look at the scales equals free and space equals free, and whether shrink is true or false, all that kind of stuff. I think that will really help you make sure that your facets basically adapt to the size of the data that's inside them. Because otherwise you could end up with quite a lot of empty space in your graph. So have a look at the scales in terms of what you want to deliberately keep consistent and what you would want to move around. The other tip to do with time series is I find sometimes the time series can be difficult to interpret if you've not got really clear visual anchors as to what's going on. So again, you would probably want to think about your data in terms of how you're going to highlight where a particular cycle starts, and if your cycles are, if the cycles in the time are moving around because of the parameterization, you'll want to have a think about how you annotate that in a way that makes sense to your readers as well. So yeah, those would be my tips on all of those.
Thank you. Fantastic.
That's okay, you're welcome. So Jonathan has a question about you've created a theme function, does it need to be added to every R project? There are several ways that you can do this, Jonathan. One, if you've created a function, you're not very far from creating your own package. So one thing that you could do is add that function into your own little package, which then means that you could call that quite easily. So I have my own package in which I've stored things like what my brand colors are, how I create my quarto slides, this kind of stuff. So whenever I'm creating a new project, I don't have to copy paste anything. I just call it straight from the package. That I think would be my recommended way to do it, simply for the fact that otherwise you're going to end up with that function, that theme function copied in different places, and then at some point you'll decide, actually, I prefer it if I do it this way, or maybe there's this little variant that I need to add in, and you'll end up with too many different versions of it. So there's a really brilliant blog post by Shannon Pileggi called I think it's something like Your First R Package in Under an Hour. And she talks you through how to do that. So yeah, I recommend looking into that. If this is something that you think would make your life easier, then having it contained within your own package is the way to go. I hope that helps. I feel bad about not having recorded the second half, so I'm gonna re-record it so that we can make sure that we've got that, but I'm not gonna hold everyone hostage to me doing that at all. Great. I'm glad this was time well spent. Do we have any other questions or concerns about parameterization? I'm gonna go and look into the curly brackets thing. I feel like I should figure that out at some point. If I can do regular expressions, I need to figure out how to do the curly brackets. Good stuff. Ah, perfect. Thank you very much. So Martina's just shared a resource in the chat about making packages, which is good. I think packages is one of these things, it feels kind of scary if you've not done it before, but if you know how to write a function, you're basically most of the way there. It's a question of, documenting it. There's a few extra files that you need, but package development has become so much easier with things like the use this package, which populates things for you. So yeah, give it a go. Give it a go. And the R community is generally pretty happy at helping out if people get stuck as well. So yeah, give that a shot. Okay. Any further questions from anyone? I appreciate we're finishing ahead of time, but hopefully that means that you've got a bit of extra free time to do something else. Or depending on where you are, maybe it's bedtime. Maybe it's past your bedtime. Who knows? Who knows? Okay. Well, if there are no further questions, then all that's left is for me to thank you all for joining. And yeah, I will upload all of this to the website so you'll get the full set of slides, the resources that I've mentioned. I'll also pop the different gests in just so that you can retrace your steps in smaller code chunks if you want to. And that will all be up there on the website for you to look at, including the video once I've re-recorded the second half of it and sent the R Medicine team an apology for a bit of editing that they need to do. But yes, that's it from me. So you're free to go. Thank you so much for joining and for your interactions, and I will hopefully see you at the next one. So I'll hang around till the bitter end, but I'll let you all head off if you're done. Thanks everyone.